Hello, welcome to Introduction to Java Programming. In this session, we will discuss about creating threads in Java. So what are the different ways of creating threads in Java? Let's understand. So in the previous session, we have understood what is a thread. So thread is a lightweight process and where the communication between switching is very less. And we have seen the advantage of threads and we have understood about the life cycle as well. Right now, let's understand how we can create threads in Java. There are two ways by which we can create Java. The first way is by extending the java.lang.thread class. And the second way is by implementing the java.lang.runnable interface. Okay, so if at all we want to create threads for the class which I'm writing, my class should extend thread class. The other way is by implementing the runnable interface. So let me actually tell you that. So for example, I want to create threads of my class A. So what this class A has to do? This class A has to extend this particular thread class explicitly. Class A extends thread, and then you have to write some logic over here. And whenever you create actually your objects in the main method PSVM, public static void main. Now directly the objects of A are going to become threads. This is the first way. So now T1 is a thread because T1 is of type A extends thread class. This is the first way. What is the second way? The second way is actually implementing. So now I am writing like this. My class A implements runnable. So runnable is the interface actually, java.lang.runnable. And runnable has a method, very, very important method. That method is actually called as run method. So run is actually the critical section of multi-threading. So this has a method like this, public void run. So that method was there in the runnable interface and that has to be implemented. So we have to implement here. We have to provide the implementation because runnable has this run method. Now directly, so in the main method, PSVM, the objects of A are not going to be, the objects are A are not going to be threads. They are just runnable instances. So you have to do an extra mechanism actually. So you need to use a thread constructor, thread T1 equal to new thread of, you can actually pass this runnable interface, this class A interface actually. Say, let's say A1 equal to new A. And this in fact can be something like this also, right? We know the interfaces can refer to the implementation classes. Runnable A1 equal to new A. And now a thread is created by passing this particular runnable instance. So this is the second way. Okay, I will explain actually all these things I will explain. But what I'm telling is there are two ways. Directly you can extend a thread and you create objects of it and they are going to be objects, threads. And second is implements runnable. Then you have to implement this run method. And then you create an object of this class A. They are runnable instances. And you need to explicitly pass this runnable instance to a thread constructor. Then thread is going to get created. So like this, there are two ways. So this is what I am telling. By extending the java.lang.thread class and by implementing the java.lang.runnable interface. Okay, in fact, if you see here in the thread class, you have several constructors, thread constructor, thread with runnable instance. So this is what we use in second mechanism. We create a thread object by calling the thread class constructor and passing the runnable instance. And you can create a thread with a name and you can create a thread with runnable instance and name actually. Okay, so either this one or this one we'll be using mostly. If at all we want to give a name, we can actually go for these two as well. Okay, so let me now actually show you this particular runnable interface and thread class. So now they're all available in the lang package. Just go to the lang package. Yeah. So in the lang package, let's find out the thread class and the runnable interface. So first, let's actually go through runnable interface. We will go to R. Here somewhere you can see runnable interface. It represents an operation that does not return any result. So that operation is going to be run actually. Now you can see interface runnable. Yeah, so it's a functional interface. Functional interface is the one which has only one method. Okay, so how many methods it has? Whose functional method is run method? So now see, there is only one method, that is the run method. Void run. So this is the run method. So any interface, whatever the members you have, by default they are public members. We need not to write public. By default they will become public. You know that this is a functional interface which has a run method. I told you in the previous session, the objective, the purpose of any thread is to execute the run method, and that run method is defined in this particular runnable interface. Okay, and now let's go to this particular thread class. Let's go to the thread class, and yeah, so here there is a thread class. Let's go inside and find out the definition, actually how the thread class is defined. So now if you can see here, public class thread extends object, because for every class there is a parent class, that is object class, and implements runnable. Thread class already implements runnable. Okay, thread class implements runnable. That means thread class provides implementation for the run method. Okay, it already provides the implementation for the run method. That's why when I extend my thread class, run method is available to me. Because thread class has already run method, when I extend, run method is straight away available to me. So now I can override that run method and write my own business. Okay, apart from that, and this thread class has several constructors, just like now I'm telling you, right? This is the default constructor, and you can actually pass runnable instance with the task and the name, and a thread with the name. But of course, we can actually have thread groups also. There are 4 constructors which uses thread groups. That means we can actually give our thread to certain group at the time of creation itself. So there are 4 thread groups things. And finally, the 9th one is also thread group and the name actually. So like that, we have 9 constructors, and there are good number of methods like get ID, get name, get priority, get state, get thread group, interrupted, join, and then sleep, join, many variants. There are sleep method with variants, the start method, and then we have the run method also. See here, void run. This method run by the thread when it creates. So if we go and see the run method, so this run method has empty implementation. Okay, this run method has no implementation. So an empty implementation is also an implementation, right? So this run method has an empty implementation actually. Okay, so what is the relation? So the relation is like this. So you have the runnable interface. You have the runnable interface, and this runnable interface is having only one method, that is a run method. Okay, so now thread class already implements it. That means the java.lang.thread class has been written like this: thread implements runnable. Okay, when it implements runnable, it has to provide implementation for that run method. So it will provide the implementation like this: public void run, and it provides the implementation like this, and this is the empty implementation. There is nothing. So now, so what are the ways to create a thread? The first way is directly extend this thread class. Okay, extend the thread class. Extends thread class. Now what happens? You will have this run method, straight away you can override that. Okay, the second way is you implements runnable. You write a class that implements runnable and provide the implementation for this particular run method. Directly they will not become threads. Later you need to pass that runnable instance to thread class constructor. Okay, so that's the relation actually. Now let's see an example to create a thread actually. So now I'm going to write a class called multi, public class multi. I want all the instances of multi to be threads. So public class multi. Now what I should do? Extends thread. So this is the first mechanism. And most of the time we will use first mechanism only. So when you say extend thread, you will have the run method. So that public void run method will be there, but that has no implementation. That has no implementation because thread will not provide any implementation, right? In fact, what we do, we are overriding that. And actually, this is the critical section for the threads which I'm going to create. That is the critical section, right? So this run method, I'm going to have something, for example, yeah. So now I'm going to write system.out.println. This is run method, is also called as critical section CS. That's what I'm printing. So not much bigger logic. And now I want to write my main method here. Main. The main, when I say multi T1, so this T1 is going to be my thread. So I'm going to create a thread now. Okay, so multi T1 equal to new multi. So thread got created actually. Thread created. So that's nothing but a T1. Okay, so threads have their own flow of execution. The threads will have their own flow of execution now. Because multi extends thread, automatically this T1 is going to become thread. So now whenever it is created, right? So it is in the new state. Now we have to make it runnable. Then only thread scheduler will pick it. We have to make it runnable. So how to make it runnable? T1 dot start. When I say T1 dot start, now it will be into runnable state. When it is in runnable state, the thread scheduler picks it, and it actually gives the access to the run method, and it goes there and prints the run method. Okay, so now let me actually show you, and later we will understand the intricacies. Java C, and let's say multi. Compile, and when I say Java multi, and it's going to print me, this is run method. See, now you understand the difference here. What I did, I just created the thread and I started it. So run method I am not calling explicitly because this run method is not our control. We can only write the business logic. So this is completely controlled by JVM, and the part of the JVM is thread scheduler. So in this program, there is only one child thread T1 created. Thread scheduler actually, whenever thread is ready, it takes it and gives the access to the run method. When I say T1.start, it will become runnable. And thread scheduler picks it and gives the access to that. Okay. So now whenever it given access, then it actually prints it and thread dies. So that is the purpose of a thread. Now we should never call the run method. In fact, here in this program, we have two threads. What is the first thread? Main thread. Right? This is the main thread. Whenever our program starts, a new thread created, that is the main thread. Okay, and main thread drives all these activities. It creates an object, that is the thread, then it starts actually, and this thread will execute the run method, and my main thread also can execute if any statements are there. So for example, now what I do is I will give some work to my main thread. Okay, so what work I'm giving is I'm writing a for loop. Okay, so for int I equal to 1, I less than or equal to 10, I plus plus. I am making my thread to print this thing like this. I am main thread. So it is printing something like this. I am main thread. How many times? 10 times. So what I do is the same thing I do in my child thread also. Okay, child thread in the sense the thread, user thread. Okay, this is the main thread. This is created by JVM, and this thread is the user thread we have created. Sometimes we call as a child thread also, but they are user threads. So what this user thread is doing, it says I am user thread. Okay, so now you have two threads. Now let's see, it is interesting actually. The output will be so interesting. Now what is going to happen? So you have a run method defined, because the run method is the critical section, and any thread that is created will be ready to execute this particular run method. Okay, their lifetime objective is to execute that run method only. Now I have created one thread and I have started T1 dot start. Now only one thread, what the thread scheduler will do, it will give the access straight away. But my main thread, what it will do, it will continue its execution, right? So main thread also will be executing. At the same time, my child thread also will be executing. So let me actually tell you with an annotation what happens there is, yeah, this is what actually going to happen. So first the main thread will get created. So the main thread, after some time, it creates T1. It creates T1, that is a thread object. And then after some time, what it will do, it will actually immediately what it is going to do is, it is going to start the thread actually. So at this instance, it starts. When it starts, T1 will have its own flow of execution, and main will continue with its own flow. So now you will have two flows, parallel flows actually. So main thread is executing, and your T1 is also getting executed. Okay, so let's come back over here to the code. Okay, in the multi, what happens here? So main thread starts here. Main thread is executing. It creates a thread and it starts it. At this instant, when it is started, there will be two flows of execution. One flow is getting executed, and another flow is this one actually. So these two things will go parallel. Okay, this is what multi-threading. So this program is example of a multi-threading. You have main thread and you have a user thread. So if you want to see the output actually, let's understand the output to understand this multi-threading concept. Java C multi demo. And now when I say here, now what is happening? See, the main thread has started in first. Okay, so when I say int I equal to 1, I less than 10, I plus plus, here, it is printing I am main thread, main thread, main thread. 10 times it got printed, and then user thread is also getting printed. But main is actually finishing its job and user thread is going actually, right? Now let me run again. Let me run again. So again, main thread finishes its job and then user thread. Okay, so this time if you see, main thread has started, it just printed one actually. One time it printed and user thread has come and user thread has printed. And then main thread starts actually. So what is happening? So this main thread and child thread, they are interleaving, right? So main thread is executing, at the same time user thread is also executing. That's why whenever I run different times, different outputs I am seeing actually. So here main finishes the job and user, and here main finishes the job and the user coming up next. Here also same, but sometimes there will be interleaving actually. So main thread and then user thread comes actually, and the main thread comes and the user thread comes. So why it is happening? Why it is not one after other? Because it is multi-threading, right? You have two flows of execution. You'll be having two flows of execution. That is the crux actually. That's the thing that you need to understand. Okay, so now, yeah, just to make you understand, this is for main thread. I just wrote this. This is for main thread part. So that means main thread will continue, at the same time my user thread is also continuing this. So two flows of execution. So in fact, what we can do is we can actually create other threads as well. So now let me create T2, multi T2 equal to new multi. And immediately we need to start the thread. Whenever we say start, then only it is into runnable. Now that is now ready for executing the thread scheduler. Now what the thread scheduler will do? Thread scheduler has now two threads, T1 and T2. Thread scheduler picks either T1 or T2 and gives some time, and then it pulls out things back and gives. So it actually switches between the threads also. Now you can see the output is going to be completely different now, because three threads will be competing now. So three threads will actually be executing now. Let's compile this. And when you see the output, now what happened? The main thread started. So main thread actually executed for some time. Then user thread has come. Two user threads are competing. And at the last, again, the main thread has come. So that means I have three flows of execution. So when T1 started, then T2 started. So T1 has its own flow, T2 has its own flow, and the main is also having its own flow. So 3 parallel flows of execution, right? So this is the example, and if you wish, I can actually change this. Rather than printing main thread, what I do is I will print my I value. Okay, so 1 to 10. Here I will print 101 to 110. Now what happens? So two threads, T1 executing run method prints 1 to 10, and this also prints run method printing 1 to 10, and my main thread prints 101 to 110 actually. So now let's see the output and understand how multi-threading is happening. Okay. Oh, sorry, here I have to print I value also. Here also I need to print I value. I just gave my main thread, so that's why my output is actually main thread kind of thing, but interleaving is happening. So 3 flows of execution is there. 3 flows of execution is there, but let me now show you properly. Yeah, now you can see. First, what happened? User thread has come. It printed 1. Second user thread has come. It printed again 1. So first T1 has gone, printed 1. T2 has gone, printed 1. Then main thread has come up and printed twice. And then 2, 3, 4. This is the other thread. And 2, 3, one more thread, 5. Like that, 3 threads are actually printing. They are not sequential, right? So they are interleaving. That means what? They are all executing in parallel, right? So this is the essence of multi-threading. Okay. So usually main thread, you will not write any business logic. Okay. Main thread is to control all these threads. Main thread is actually control the action. So it creates an object, it starts it, creates object, it starts it, like that. So this will be a proper example without having any logic in the main thread. I am going to write this. Let me actually show you. Yeah, so now what happened? 1, 2, 1, 2, 3. So these 2 threads are executing parallelly, right? Just like I told an example, right? If at all you want to book a ticket and 100 users are booking, so each user is a thread. All will execute parallelly, and if the turnaround time is 3 minutes, and within 3 minutes all the 1,000 tickets will be booked, because you will have parallel execution, right? So this is what multi-threading, and this is what extending the thread class. Public class multi extend the thread class, and you can create as many threads as possible. Okay, so now I want to actually go to the next one, that is by implementing the runnable interface. So the whole of the program will be same. So I will take all these things and I will go over here. Yeah, public class runnable demo. So what we do, this runnable demo is not extending a thread class, but implements runnable interface. Implement runnable interface. Whenever you implement runnable interface, we need to provide implementation for the run method. So I am providing the implementation over here, the same implementation. And in the main method, we need to now see it. Okay, so whenever we implement runnable, we have to provide the implementation for the run method. So we are providing the implementation over here. Fine. So now what I do, I will create instances of this runnable demo. So how I can create runnable instances? Runnable R1 equal to new runnable demo. We can do like this, right? Because runnable is the interface and runnable demo is the class. So now interfaces can refer to their implementation classes. So one instance was created, and now I can create another instance, runnable R2 equal to new runnable demo. So these are runnable demos objects only, they are not threads. So how to make threads actually? So now we need to use the constructor that is called thread runnable R. This constructor has to be used. We can pass runnable instance to thread class constructor. So explicitly we have to say thread T1 equal to new thread of this runnable R. The runnable instance, that is R1. So now this thread R1 is going to become a thread become T1, and this is a thread actually. Now thread T2 equals to new thread of R2. New thread of R2. So these runnable instance I can pass. Now once the threads are created, they will be into new state. So now you can actually say T1 dot start, and then we can say T2 dot start. So when they started, what happens? They are eligible to execute the run method, and thread scheduler picks them and gives the time, and they will have parallel flows of execution. Let's see here. Let's see. So the class name is runnable demo. So let me compile Java C runnable demo.java. Compile, and then actually I say Java runnable demo. Now you can see the output. So now two threads are there. So two threads are interleaving actually. So first thread printed 1, 2. The second thread has gone and printed 1, 2, 3 or 1, 2. And other thread may be coming up, and 3 and 3 they are sharing. And other one is printing 3, 4, and then 4, 5, 6. So that means two threads are actually working parallelly, right? If they are not working parallelly, we will actually see 1 to 10 getting printed and 1 to 10 getting printed. But here what is happening? There is an interleaved output, right? So T1 is doing something and T2 is also doing something, right? So this is what multi-threading and parallel execution of the threads. So your book ticket method, we have to call in the run method. Now all the threads are going to call that run method, and book ticket method is now being called by n number of threads at a time, and that is being executed parallelly, right? So it will not wait for one method to get completed. Okay. So now in multi-threading, you should not actually call the run method. You should just say, just make our threads runnable. So when they are runnable, thread scheduler will pick them. So that's the point. So for example, what happens? you are not making them start runnable, but straight away you are calling. Let's say you are saying T1 dot run, and here you are saying T2 dot run. T1 dot run and T2 dot run. So what happens here? So threads are not into runnable state. They are just started. They are not ready for execution. So now here what happens? It behaves like a normal method. So there is no error actually. It behaves like a normal method. So how normal methods will execute one after other? So you have a method that is called run method. T1 dot run, it completes, and after that T2 will go and it completes. So now you will have a sequential output. So there is no multi-threading. Let's see Java C runnable demo and Java space runnable demo. You can see 1 to 10 getting printed. T1 dot run, T1 finishes. After that, T1 dot done. So if you are doing like this, in order to book 1,000 tickets, it takes 3,000 minutes, because one after other it should happen. There is no multi-threading. You have threads actually. You have threads, but you didn't make them runnable, and we are calling them. So this we should never do this. We just have to make them runnable. The thread scheduler will give them the time based on certain algorithms actually, based on certain algorithms. Now let's see. So now I am just making them runnable, and they will actually run parallelly. Now you can see parallelly they are getting executed 1, 2, 3, 4, 5, and then thread 2 has come, and thread 1 has come, and thread 2 has come, thread 1, like that they are interleaving actually. So parallel execution is going to happen. So when you run again, and this time you will see different outcome. When you run again, this time you see. So the thread scheduler actually picks either T1 or T2, and it follows certain algorithms internally, and we don't know what algorithm it follows. It may be round robin, or it is first come first serve. Okay, it is based on certain time slicing. So different algorithms are there for scheduling. Okay, so this is the second way, yeah, to create objects, thread objects in Java by extending the thread class, and second is implementing the runnable interface. And these are the constructors. And of course, there are some important methods. Start method is there, which is required so that thread is runnable. And we have run method, because this is the critical section. This is the critical section which has no implementation in the thread class. We have to provide our own implementation. And there are few important methods like sleep, join, current thread, get name, get priority, etc. So we will actually discuss all these methods in the next session. So as of now, we could able to create threads in two ways in Java, by extending the thread class and by extending the runnable interface. So why, the other question is, why two ways actually? Why one way is not enough? For example, public class multi extends thread, straight away my objects are becoming threads, and we could able to create threads, right? So why we can use only this method? Why we have to go for the second one also? So this approach has a problem actually. This approach has a problem. What is the problem? For example, my class multi extends some class A. My multi extends some class A, and I want actually my multi instances to be threads. Then it is not possible, right? This is not possible. We don't have multiple inheritance. If your class is already extending some class, and again you want thread to be extended, it's not possible because multi-threading is not there. Multi-threading is not there. So that's why if at all your class is extending some other class already, then you go for this approach. Public class runnable demo, I can write something like this, right? Extends A and implements runnable. You can say like this. Extends A, implements runnable. A class can extend other class and it can implement a number of interfaces, right? So if you have this kind of requirement, we have to go for this action. That's why we have two approaches. We have two approaches. So hope you have understood. And the next session, we will go and understand about sleep, join, and current thread methods. Thank you.